great to see
This meeting is being recorded.
Here we go. Yeah, it's great to see some familiar, some unfamiliar faces. It's great to have you here. It's my pleasure that Bruce Hoppe here has agreed to give a talk. And actually, I haven't seen the talk yet, so I don't really know what you're talking about, Bruce. But I've been at a conference 4 or 5 weeks ago. Uh, I've been speaking on a different topic, but I found a workshop that you guys organized very intriguing, was very interesting. And you had only 5 minutes or 10 minutes to pitch your project, which led to the workshop organization. Now you have the full hour, and it's a great pleasure to have you here. I'm looking forward to learn more about your work at MIT. So over to you. Thanks a lot.
Thank you very much. And I'm really pleased to be here virtually, talking about developing the field of software performance engineering, obviously. And Tobias and I met at an earlier event, and he basically invited me to basically say more about really what it means to develop a field, but in particular, software performance engineering. And so that's where we're headed for the hour that we're together today. This is an outline of what I'll be talking about. I want to motivate software performance engineering. And then with that, I want to frame our problem, which is developing the field of software performance engineering. And then with that framing, I'm going to talk about developing any field, regardless of topic or interest. And then we're going to take that and apply it specifically to what we care about here, which is software performance engineering. And so essentially we'll kind of take the first half going through sort of steps 1, 2, 3, and the second half thinking specifically about the Fastcode community that I'm community manager for, which is, you might think of an instance of a field that is dedicated specifically to software performance engineering. Let's motivate the topic. And let me just also say that I'm very happy to take questions. I think Chris is monitoring the chat, and someone's in the room, or I may have the names a little bit mixed up, but please feel free to raise a hand or put a chat and someone stop me if any questions come up. So just a quick definition of software performance engineering is making software run fast or otherwise consume few resources like time, space, or energy. So obviously that's important, but there's a little trick. What properties of computation matter more than performance? So I'm going to pause here for a little bit of audience participation. Please, anybody feel free to put it in the chat or even just unmute yourself, because I think we're a fairly small group. What are some properties that matter more than performance? Let's hear it. Maintainability. Did I hear correctness?
Yes.
Great. Any others?
Resource use.
Resource use.
Efficiency.
Efficiency. So efficiency is really close to performance in this context. I may just push a little bit that I'm not sure that that's necessarily different. But we've got some great examples here, and we could continue to list properties that are more important than performance. So yeah, why do we care? And one reason that we care, and this is something I learned from my boss, Charles Leisterson, who's at MIT, is that performance is like currency, is something that we can use in exchange for all those other properties that we really truly care about, like correctness or maintainability or composability, so that it fits with legacy systems and user expectations. So just to illustrate what I mean by currency, suppose you're in that scene there in the desert, and maybe your car broke down, or maybe your car didn't break down. And I give you a choice, like, do you want a bottle of water or do you want a $10 bill? or 10 pounds, right? 10 euros. And which one are you going to pick? And it kind of depends. Most of the time, you'll take the $10 because it's quite valuable in exchange. And you could buy a lot of water for $10, probably more than that one bottle. On the other hand, if your car is broken down and you're really thirsty, my goodness, you need water to live, right? So you would take the bottle of water. So there's a distinction that we're making of use value versus exchange value, which goes all the way back to Adam Smith and the invisible hand in economics. And so use value, exchange value, two different things. And performance, we like to think of as the currency of exchange in the world of computation for everything that you also care about. So that makes it pretty important. Now let's also think about the history of the importance of software performance engineering. Back a little bit before I was born, there was kind of no choice, but you have to care about software performance engineering because when your computer fills a whole building and it only has 524 kilobytes, my goodness, you have to use resources efficiently. Otherwise, you don't even get to use the machine at all. So in the beginning, everybody cared about software performance engineering because that was the only way that you could even fit your program into the machine. Of course, it didn't stay that way for long. We can see a little bit of an evolution here as machines got smaller on the outside, but bigger on the inside, faster, cheaper. And so we run into what's famously known as Moore's Law, which I'm paraphrasing here because he was at Intel. And he said, yep, the computational capacity of our chips is going to double every 2 years. And that's just going to keep happening. And this is going to have a huge impact on the marketplace of computation. And he was almost exactly correct. So for decades, I'm going to estimate here a solid 50 years, performance came for free. All you had to do is wait for Intel or anybody else to double the computational capacity of their chips, and all of your problems, all those things that you want to buy with performance suddenly become free just because you waited another year. Fantastic. So the image here is, it's like printing money, except without inflation, right? And so how would you manage your household budget if you knew that if you just waited a year, well, you'd have twice as much money as you do this year? Like, what would become of your economic budgeting, financial management? So those are kind of heady days of free performance. And we now arrive, arguably, but I think in our world of computer science experts, it's pretty well agreed that Moore's Law is dead for several years now. I'm showing you a story that was published about 5 years ago in Science magazine with some very influential authors, including Charles Leisterson, who's the kind of the creator of the Fastcode community that I'm managing, saying there's plenty of room at the top. They're referencing a much earlier comment from, oh my gosh, I'm forgetting his name, but a famous physicist at Caltech who said there's a lot of room at the bottom. So they're putting this story in context and saying Moore's Law is over. So what happens to performance? How are we going to increase performance now that we can't just have it for free? Shoot, we have to work for it now. So we're now getting to the second item on our agenda, framing our problem, which is software performance engineering, and how to increase performance is the beginning of framing our problem. Haven't quite justified the software performance engineering. In the science paper that I just mentioned, there are three approaches that they describe for how do you increase performance now that you actually have to work in order to do it. One is software, another is better algorithms, and a third is better hardware. And they observed that, wow, it takes a lot of expertise and infrastructure to be in a position to change hardware for the better. And also a lot of expertise and perhaps infrastructure to be able to change algorithms. Those are just very rarefied realms of making a difference. Whereas software, how many people develop software? And how hard is it to learn how to do something to do a better job at that? So the point here is that by far the most accessible in terms of the number of people and the cost, the barriers to entry, by far the most accessible of these three ways of increasing performance is through software. So there's our motivation for software performance engineering and framing it as a critical problem that really matters, having been dormant for the kind of glory days of Moore's Law. So now the turn we're going to make here is taking our problem that software performance engineering is important and saying, yeah, and it's way bigger than just our problem, it's everybody's problem. And this is sort of the genesis of making Fastcode as an engine for developing the field of software performance engineering. Quoting a proposal co-authored by Leisterson again, I'm just going to read it. Our major concern is how the whole field of computer science will fare without software performance engineering as a community that provides common infrastructure, a shared understanding of the principles, and a lingua franca. It'd be chaos. So the way they say is software performance engineering in that event would require arcane knowledge only available to narrow domain experts. I mean, maybe that's okay if you just want to be in an ivory tower, but for the field of computer science at large, and society, that's bad news. So they describe it as a choice. Software performance engineering can be tedious, basically just the realm of ivory tower experts, the high priests, so to speak, or it can be fun, cheap, principled, and democratically available to the average programmer. So we have just teed up the frame that we want the best for computer science. We want democratically available software performance engineering. And oh my gosh, we even have an answer, and it's called Fastcode. Now, there's other answers, but this is ours. The problem is developing the field of software performance engineering, and the answer is Fastcode. That's an open source community for making software performance engineering easy and fun. So soon I'm going to be talking specifically about how we do that with Fastcode. But I want to just take a half step back and say that, well, we could also be talking about developing any field, not just software performance engineering, and still would have a lot of relevant stuff to think about when it comes to the task at hand of increasing performance. So I want to give a few examples of developing a field, being kind of loose, informal about what do I mean exactly by field. I'll get a little bit more formal. So one example of what I mean by developing a field is everything that's been documented by the National Science Foundation and their relatively new program called Pathways to Open Source Ecosystems, which is the major funder for Fastcode, right? That's where my funding in particular 100% comes from. We're one of the inaugural grantees when this program was created. We got one of the first grants. And how fortunate was that I was literally hired months before NSF announced that they were going to start this program. And we're like, wow, perfect. So the idea of NSF POSE, Pathways to Open Source Ecosystems, is that a grantee already has mature open source software. The technology is present, but the impact is lacking. It could be more. And so what NSF wants to do with this program is say, great, let's make your technology meaningful, impactful by helping you transition from this kind of de facto informal, yeah, we just have the technology and some people kind of using it, to basically having a more formalized, intentional framework around it that's governing and like basically doing how I think of my job as a community manager, being an evangelist and a little bit of a maintaining some container for the long-term sustainability and impact of this technology. So NSF Pose is all about that for any open source content. It doesn't even have to be software. And so that's one way that you could dive in and say, well, how do they think about developing a field? They would never say a field, but you could certainly take the language that we're using in this talk and just read their content in that way. Now, here's an example that may seem like it's coming from a really different world. It happens to be a world where a lot of my career was spent before I joined the team at MIT, working in a community of computer science professors. Before that, I was spending quite a bit of time helping social change projects funded often by nonprofits who weren't trying to increase software performance. They were maybe trying to mitigate climate change or just name a cause. And if there's a foundation that wants to have an impact and trying to do collectively ways to produce that impact, then how do you make sure that that happens? How do you measure how well that happened? There's a whole body of literature, and that's essentially the world that I come from before I got back into computer science with my community manager role at Fastcode. So again, just stepping away from technology as a specific domain to any kind of social change. And our particular example here would be, gosh, we want people to be using their host environments efficiently. Continuing in that social change world, here's some work that I wrote a few years ago with a colleague, where we were just really assessing what are all the kinds of things that people do in that social change world where they're trying to essentially develop some kind of collective impact, some collective action. And as you see in the abstract, the highlighted part there, try my laser pointer, look at that. We put a framework together. It's less of a theoretical framework, and it's more of a practical observation of having spent many years looking at collective work, leadership networks, as we call it in that paper. How would you categorize them? And here's how we categorize them. And that one of the networks that we observed, we call field policy, which is 100% what I mean when I say field. And you can think of it very much like the intuitive notion of a field, even as computer science or biology or mathematics are all fields. So before I get to the field policy leadership network, let me just say that there's 4 types of leadership networks, and we don't need to think too hard about what is leadership. Your intuition is fine. Network is not really internet network. It's just network of people, social network. The top one, peer leadership network, if there's any community managers in the audience, you may think of peer leadership as what you're often trying to do, which is just get people to share. Oh my gosh, you had that problem too? Like, you hate grading papers? So do I. How do you do it? So a peer leadership network can be just that peer-to-peer bonding. Organizational leadership network is classically you work for a company and there's the formal org chart, but there's also informal ways that people make things happen. The one that we really care about here, Field Policy Leadership Network. I'll get right back to that. Below that is Collective Leadership Network. That one, in my opinion, is the hardest to nail down. And I'm just going to say, let's just let it be there. I'm not going to spend this time trying to refine the definition between field policy and collective leadership. So on the field policy side, I've bold-faced in red two big things: that the leaders share a commitment to influence the world or in a particular way, right? So our particular way is going to be software performance engineering. We want to increase performance in a post-Moore world. And so we're committed to that particular way of influencing the world. And with all of that in mind, we're going to find common ground, mobilize support, and influence policy and the allocation of resources. Okay. So another example, very much adjacent to the social change space. This is from Stanford's Social Innovation Review. And they use the phrase collective impact. And so in that world, that's very much a jargon, kind of term of art. And collective impact, I would describe as, how do you develop a field? It's not exactly the same, but here we can think of it very much as, how do you develop a field? And again, I've highlighted in red what they summarize from basically 10 years of really thinking explicitly about, how does collective impact work? This is a kind of issue 10 years after the first big interest in studying collective impact. And so you see that they say important actors from different sectors with a long-term commitment to solving a specific societal problem. So I'm just going to back up and say, very, very similar to Field Policy Leadership Network, that there's a commitment to a specific change that we all believe needs to happen. And so then the trick is overlooking a lot of other differences, basically, and exploiting those differences in order to achieve your shared objective. So I want to pause for another moment of audience participation here. And you see that there's some bullets there that are going to hold what the Stanford Social Innovation Review says are keys to success. And there's only 5, but of course there's way more than 5. And I wonder if anybody wants to just shout out, what are some keys to success if you're trying to have collective impact as we've defined it here? Just intuitively.
Community engagement.
Sorry?
Community engagement.
Community engagement, great. Couple more, anybody?
Shared definitions or common definitions?
Oh my gosh. Have you, I feel like this person's been studying. That's a great answer. Thank you.
We have number of people engaging.
Number of people engaging, fantastic. So I'm gonna move ahead and show what they list. And of course, we could elaborate and have many, many more, but these are their summary of the keys to success: a common agenda, shared measurement system, mutually reinforcing activities, ongoing communication, and this last one is maybe a little bit wonky, an independent backbone organization. So we're going to dive into the backbone organization, but I think that shared measurement system, for me, is a lot of what I heard when one of the suggestions was something about a common framing, or like shared vocabulary. That's absolutely how I read the shared measurement system. So I want to dive into independent backbone organization. This is absolutely how we thought about Fastcode, or certainly I thought about Fastcode as I was helping to write our proposal, and basically say to the NSF, how are we going to be intentional about taking our mature technology and making it impactful? We're going to be a backbone organization. So from the same Stanford social innovation, they go on to say, here's what a backbone organization does as a function. And I would offer this as a generic list of how to develop a field. You're going to guide vision and strategy, support mutually reinforcing activities, establish shared measurement practices, build public will. There's that engagement that we were talking about, advance policy, and mobilize funding. And again, we could come up with a much longer list and elaborate, but they did the tough work of trying to distill it into just kind of the essential ingredients of being a backbone. And the argument that's being advanced in that article and all of the years before it is that this is a real key way to develop a field using our own language here. To achieve collective impact is how they would put it. So now we're hopefully, we're right about the halfway point and right on time. We're going to go to agenda item number 4, specifically, how are we developing the field of software performance engineering? That is the work of Fastcode. And I think of Fastcode as our version of being a backbone organization with NSF POSE funding. And so, of course, it's also framed as building an open source ecosystem. So I'm redrawing here the journey of POSE as the National Science Foundation presents it, where you begin as you got the mature technology, but maybe not much else. And then, you have a great kind of bunch of scaffolding, sort of infrastructure, users, contributors, and all kinds of things to make it sustainable and impactful. So it isn't quite that simple and direct. Our journey is not a little direct line, but kind of a wandering, which is, I think, just part of what it means when you're functioning as a backbone, is you're learning as you go, juggling all these diverse tensions that come at you from every direction, because as a backbone, that's where you want to be. So I'm going to elaborate on this. Now, from the National Science Foundation's perspective, they do not talk about backbone organizations. What they talk about in its place is a POSE managing organization. So this is just clipping a diagram from their literature on the program, Pathways to Open Source Ecosystems. And I observe that what they describe in a managing organization is similar, but not quite what I would think of as a backbone. It just doesn't quite fit. So I want to just note that and give a little backstory to why the difference. Why are we not more of a managing organization? Why are we more interested in being a backbone? And so the backstory is that when we originally applied to be a NSF POSE open source ecosystem, we were really focused on, and we continue to hold dear, OpenCilk. And OpenCilk is a compiler that makes it easy to parallelize your C and C++. It is one tool. I'm presenting it here as a hammer. Now, eventually, and we knew this transition was coming, we rebranded, and we were less about being an OpenCilk ecosystem and more about being a Fastcode ecosystem. Fastcode is not any particular tool. It's not a hammer. It's a whole box of compatible tools, or even incompatible tools, like choices. So the hammer is in the toolbox, but there's lots of other tools as well. Fastcode is about software performance engineering. It isn't about one particular open source software. And so if we look again at the National Science Foundation description of a managing organization and at the backbone functions, and I'm not going to dwell on this too much right now, but what I see is that the managing organization is really drilling into the details of, we have open source software that is a proxy for the change that our field is going to have on the world. That change happens because our open source software is great. Whereas in the Fastcode world, where we're a backbone, we don't have a clear answer to what is our open source software. We do have a clear answer for what's the change that we want to have in the world. That's about software performance engineering. That's about improving performance in a post-Moore world where it doesn't come for free anymore, and having that be democratically accessible and fun. So the backbone functions make more sense to my eye, although it definitely complicates the story that we continue to need to tell as being an NSF POSE grantee. We have a little bit of an identity crisis, you might say, in terms of like, what is the open source content of Fastcode? And OpenCilk is still there, and there's some other open source content, but there's really just a passion for software performance engineering. However, we can enable that to advance. So as we continue to think about Fastcode through the lens of being a backbone organization, I want to take this list of the backbone functions and observe, broadly speaking, two different kinds of functions, which I've colored as red and green. And the red ones I'm going to call external PR, public relations, and the green ones I'm going to call internal operations. And with these two categories, I'm going to look in more detail at what we've been doing with Fastcode. So very briefly, in terms of Fastcode's backbone of public relations, we are really fortunate to be led by Charles Leisterson, who's a hugely influential senior computer science professor. And so he, through work that the rest of us don't really need to be a part of, does a tremendous work on the PR side. And I just want to give one little example, which is the Computing Research Association. That's an association, perhaps it's American or North American, basically chairs of computer science departments. Every 4 years, they write a very short list of papers and say, these are the key things that deserve national attention, national funding. And guess what made the list of, like 4 things that the country needs to care about? They said, on behalf of all computer science departments in the country, software performance engineering is one of the top 4 things. So that's definitely PR for developing the field of software performance engineering, which I'm not directly involved in, and I'm not going to say much more about that. I'm going to move into the stuff that I'm much more involved in, which is the operational kind of internals, which again is really about mutually reinforcing activities and the shared measurement practices. Here's a description of Fastcode: for making software performance engineering fun, cheap, principled, and democratically available to the average programmer. We've organized Fastcode around 4 pillars, which are very much related, but maybe indirectly, to the operations that I just mentioned. So the 4 pillars are research, education, technology, and skill building. And let me just point out that education is really about if you want to teach software performance engineering, and that can be very hard for a few reasons. Skill building is if you want to learn with or without someone trying to teach you. Perhaps you're just doing it on your own. So each of these we really pay attention to as a dimension of how are we helping advance software performance engineering? And I'm going to give examples that kind of cover these bases. So backbone operations of Fastcode, this is kind of my job to make sure, especially the blue things. The red one I'll introduce as well. Skill building with speed code. I'm going to give you a little demo of that in just a second. And then the blue stuff, these are the mutually reinforcing activities that a community manager would probably be familiar with a lot of these kinds of things, like making events, publishing a blog, and having communities where people share things. So this is just a preview of where I'm headed with the last 10 minutes or so. So speed code, this is a huge part of the Fastcode infrastructure. This is platform that a colleague of mine has really designed and built. And it's like it says here, it's an online place where you can practice software performance engineering, where all the complicated things that you might have to set up if you, let's say, wanted to install the right kind of compiler that could handle parallelism and wanted to do the right kind of measurements that are like not kind of clouded by all kinds of other conflicts on your machine. Well, if you use speed code, it takes all those complications and makes them go away because it's already figured them out for you. You might have heard of LeetCode. If you're a professor, surely your students have heard of LeetCode because that's a place where they would go to practice the kinds of programming problems that they would have to do in an interview for maybe Google or some big software company. Speedcode is similar in being a practice platform, but it is not about just generally programming something. It's about software performance engineering. It's about taking existing code and making it faster. So we're going to give you a 2-minute demo of speed code, just so that you can kind of get a sense of what I mean by skill building and providing a place where things are set up for you to practice. So we've now gone inside speed code, and we're presented with some C code that is solving matrix multiplication, everybody's favorite problem. And we want to make this code run faster as a canonical exercise in software performance engineering. So I've now started a video, and what I've just done here, let me try to stop the video. Sorry, the video ran away from me. So what happened in the first couple seconds of the video is that we ran the code, and we saw on the left sidebar comparing the speed up of our code versus some benchmarks. And we have no speed up. Our code is not fast. So we have a long way to go. And of course, this video is kind of giving us a very fast track of what would happen in a speed code session. So our next idea is, okay, we're going to reorder the loops of our matrix multiplication and then run the code again. And you can see it's running and measuring. And if you look, you can see over on the left, well, we had a little bit of speed up. So we've improved, but we still have quite a ways to go. So there's just a lot happening that speed code is taking care of in terms of measuring and giving us some comparisons. So now we're looking for the next level of making things faster, and we get the idea. We're using OpenCilk here, which is part of speed code. We're going to parallelize with Silk 4 that's saying you can do every one of these iterations in parallel. So we're parallelizing it, and we can't wait how much faster it's going to be. And there's a race. Our code is non-deterministic. But luckily, there's a race detector. And so we do a little diagnostic, and we find the races. And thanks to that information, we're able to go in and fix the race by saying, yep, that loop's not going to be parallel. And comes the finale where, boom, wow, it's way faster. So that's a very, very quick introduction to establishing shared measurements in practice. Speedcode has a library of pre-curated great problems for software performance engineering with all of this stuff already there. So moving on to other pieces of developing a field of software performance engineering, we've been supporting mutually reinforcing activities. And here's a list. And I see I've got about 5 to 10 minutes left, which will be fine to go through these. I'm not going to, I just briefly talk about these activities. And these are some of the universities that have been co-organizing these activities, not just MIT. So one of the activities is the Fastcode seminar, and that's monthly virtual talks. You know, a little bit like this seminar, but I'm giving kind of a meta talk about the field of software performance engineering as opposed to a particular technique like domain-specific languages, which Saman gave a great talk on that a few months ago. So we organize those and try to make them, that's kind of our most advanced channel, I would say. Tends to be professors giving those talks, also industry. In parallel with that, we have a Fastcode blog. And I want to spend a little bit of time on a thread in the Fastcode blog, because there's a post in the Fastcode blog about looking at task parallel programming platforms, which is actually connected to why am I even here? Because it was this work that led to a seminar where I met Tobias and got the connection to Durham. So the backstory is that Fastcode is all about making it easy for people to do a good job of software performance engineering. And so I thought, gosh, my friends just told me about this taxonomy of task parallel programming platforms. Let's promote it and let's help people break it down and apply it to their own cases. And the taxonomy did not include OpenCilk. So of course I added OpenCilk and talked with a couple of my colleagues in the Fastcode community about how can we like really nail down a new updated version of this taxonomy to make it easy, as we said here, to find performance engineering El Dorado, where the money of performance engineering just comes for free once again. And so if you go onto the Fastcode site, you'll see the taxonomy that we produced. And then kind of came a tough realization, which again, my colleagues helped me to appreciate this, that there may be a difference between talking about software performance engineering, like I'm doing, versus doing software performance engineering, which maybe some of you are doing. And when you talk about it, when I talk about it, gosh, like these taxonomies are great. But when you're actually doing it, there's so many specifics that you cannot escape. And maybe my taxonomy is going to seem like that doesn't even begin to touch the software performance engineering that I actually have to do in my jungle. So we recognize that. And in the future, I'm definitely interested what's happening in your jungle. And with that epiphany, I'm just going to fast forward past this slide. We organized this event at HPEC just a month ago with me and 3 other speakers to basically talk about platforms and have a 90-minute discussion. What is happening in your jungle around software performance engineering? And ask us questions about what are the choices of platforms that might be useful or not useful, depending on the kinds of constraints that you encounter in your actual work. So we're really trying to again, make mutually reinforcing activities and bring different voices together, so that architects of these different platforms are looking across the conference room at people who are trying to do software performance engineering for real. So we want to do more of that. So that was the HPEC conference, which you can see in the middle of the examples here. And I have just a couple others that I'm going to mention before wrapping up, which is the Fastcode Programming Challenge and an instructors community. The Fastcode Programming Challenge is a competition of programming that is challenging people to basically do software performance engineering. We just had our first competition this year. It was the culminating event was a workshop at PPOP, where all of the competitors who submitted solutions presented their work in a special workshop. And that was really great to hear, and has definitely catalyzed momentum for second and third and fourth editions. We're actively courting industrial perspective and contributions to make future problems even more interesting and hopefully relevant for the students, by and large, as students who are actually in the competition. Here's a page of all kinds of events that we're trying to basically promote, not just our own, but any conference that we think is core to advancing software performance engineering. And finally, with my last couple minutes, I'm going to talk about the instructors community. If you're interested in teaching software performance engineering, you might find it challenging, both because it's so interdisciplinary and because the infrastructure and administration can be daunting. So this is a web page on the Fastcode site where we're presenting things that we hope will help, including other classes where universities are teaching it. And if you see that highlighted link right there, there's this amazing blog post that John Davis wrote about his personal experience taking Charles Leisterson's materials and porting it to his own class at UC Davis. And if you scroll down, you can see that there's, in addition to all this publicly available stuff, we have a members only space, which you can just ask me to join. And when you get in there, we're now looking at a private repository where about a dozen universities are sharing all kinds of materials in private with other professors about, well, here's how I teach software performance engineering. How do you teach software performance engineering? So this is actively being developed along with conversations around it. So that wraps up my talk, and I'll turn it over to questions or any kinds of comments. Thank you.
Thanks very much, Bruce. I have perhaps a leading question. You began the talk with this analogy about economics, that performance is the currency that we use in computing. I was wondering how you might extend that not only from the high end, where I think this is more or less clear, but actually in the low end. The thing I have in mind is the advancements in performance that the Python community has made in the last few minor versions, which is kind of astounding, but it should be for the amount of money that Python has. And I'm kind of curious how that fits into this paradigm. Just like very broadly speaking, I feel like those people are more interested in writing performant code in Python than they are in, say, OpenCilk. Right?
Thank you, Tobias. So I'm going to take a guess as I try to interpret the question, that I think with that performance as currency metaphor, to me, that really activates this picture of, oh, I used to just get free money, and now I actually have to be disciplined about financial planning? And does that discipline take the shape where I am explicitly figuring out techniques for budgeting, or, and I've kind of maybe spent more time talking about those approaches, or does it take the shape that, oh, I just use this package, it's called Python, and they have behind the scenes like done all the homework and packaged up their own financial responsible kinds of approaches within the language. And if I we're giving just one more example, we have an event that's coming up. Fastcode's organizing at Peepop in Sydney, Australia in just a few months about coevolution of algorithms, compilers, and hardware, which is specifically about that kind of trade-off of, well, if someone figures it out, then eventually it gets into a language that's compiled or interpreted, and the rules continually evolve in a back and forth. I hope that starts to answer your question.
Yes, thank you. Do we have other questions?
So I have one. Engineering is typically means that there is a strict pathway to solution, often certified or agreed upon. I don't see that in performance engineering. I don't see it even in performance analysis. So where am I wrong? What is missing there?
Can you repeat the question?
So
Go ahead.
yeah, performance engineering in general means solving a certain problem, but in a systematic way. This I'm not aware of any systematic way of performance analysis slash then optimization, which should be the next step. So how is the community, how do you think should the community create this knowledge body and that workflow body?
Thank you. So I agree that agreed upon approach is lacking, and that's, I would say, one of the key arguments that comes from that kind of manifesto that I was quoting about. We have a choice. It can be all like arcane and ruled by high priests, or it can be democratically available. And I think those engineering choices are currently being ad hoc made up by the experts. And the vision is that through a process that remains to be instantiated, standards, principles will be distilled, and it will become more of a methodology, but we're not there yet. But it's definitely held as an explicit goal for there to be rigorous principles of software performance engineering. In other words, they don't yet exist. And this is something that needs attention, is the argument.
Could there be more than one methodical way of doing things and still, count as engineering? That's an honest question, not a.
That's a great question. Like, I personally am about holding a space for the real experts to debate that, because I'm more or less able to keep up with what's happening in software performance engineering after I hear it enough times, but I'm not qualified to know the specific ins and outs of some of the alternative approaches. But I certainly think that, yes, there's certainly room for more than one. And then maybe at some point, like, for example, once something, to get to my coevolution example, once something gets standardized in a mainstream compiler, perhaps that's the standard. But yeah, it's a very good question. Thank you.
I realize we're at time, but I have a quick, not quick, but a question, a personal question, personal-ish. Do you feel a pressure from managing the complexity of a network or a like the complexities within a network? And I would say the entropy that kind of is out there as a possibility. Like I'm involved with a community and it just feels like at any minute it could just it's so self-organized.
Mm.
And how do you allow for the natural fluctuations, the healthy ones, while also enforcing standards and standards?
Oof. What a great community manager question. So in my position, I have maybe an answer partly just sort of forced upon me. Like the early programmers had these incredibly limited computers forced upon them, where I have so little control over the members of my community, which has some fairly mature technology, to use that word very liberally, but not a lot of standard practices when it comes to anything other than kind of benevolent, like everybody does what he or she wants to do and it's all going to work out. I kind of think of, I think it's fair to say, Fastcode as a little bit like, if you know your American history, apologies if you don't, the Articles of Confederation as opposed to the Constitution. What happens when Pennsylvania and New Jersey have different foreign policy? Who knows? So we haven't laid down like the federal Constitution yet. And I live in acceptance of that reality and remind my beloved colleagues that that's what we've got.
That's a very helpful
so-
analogy. Thank you.
Sure.
Are there any other questions? If not, then let's thank Bruce again. Thank you very much.
Yeah, thanks a lot. It was good.
It's really a pleasure. Thank you, everybody.
Thanks. See you.
So I guess I'm the one who ends the meeting. Okay.
Yeah.
Talk to
Thanks
you
a
later.
lot. See you.
Bye.
Bye.